we're going to take this idea of writing equations from graphs, and we're going to go back and talk a little bit about line of fit. This is going to take us back to last year when we were talking about scatter plots. And I'll put a link on here to give that, if you want to go back and look at that, that old video, if it kind of refresh some of your memories, go right for it. So, all right, well, let's dive right in this. So, we modeled situations involving constant rates. We're going to do scatter plots, and we're going to write equations of this, and then we're going to use this to predict data based on the information we get. So, let's talk about scatter plot. What is it? So it's a graph we use to determine if there's relationships between data. And so they're going to show us trends a lot of time. And if you remember last year, we talked about positive correlation, right? It's when you sort of look through this, look through the data, and it looks like it's rising as you go. Well, and then if you have positive correlation, then you're going to have something that looks like negative correlation, right? So looks like it's going down, right? Maybe as time goes on, oftentimes x will be a time unit. So as time goes on, the values decrease. So that would have a negative correlation. And then finally, you might have something that has no correlation, right? It looks like, you know, the data is all over the place, and it doesn't really look like a line would best, or a straight line would best give a sort of sense of what this data is saying. And sometimes you see this as being called a trend line. That's another way that people will to describe this. So make sure you have an understanding. If you sort of follow along here, what you sort of notice is that that looks a whole lot like slope, right? Positive slope, negative slope, and this one isn't necessarily zero slope. It's just there isn't necessarily a slope that works for this. There's no average rate of change that really will work. All right, so let's practice. Bird population, okay? This is just going to give us a whole bunch of data on active clusters of birds, and we're going to graph this according to the years since 1990. Okay, so the scatter plot has already been created, and a line of fit has already been drawn in there, okay? Now, if you remember, if you're not totally sure about what line of fit is, then I really encourage you to go back, watch that old video, and just kind of get an idea of it, okay? You won't have to watch the whole thing. You can just watch parts of it, but I think it'll refresh your memory better than me to re-explain it now. Okay, well, if you're looking at this, we're going to use the line, okay? Once we write a line, okay, or write an equation for this line, we ignore the data that's given. So we're really going to just ignore all of this data here. We're really just going to ignore this, okay? And I'm just going to focus on the line itself, okay? So we're really just going to focus on this line here and not the points, okay? And that's really the important part, is that when you are going to generate your equation from this, you focus on the line itself, not the points that are there. Now, you usually don't pick points that are there. Now, you see there's a red dot on here, and the red dot is because it's giving us one of the points, right? So 2, 20, let's do it in red. 2, 20 looks like a real nice point here, okay? So I'm going to use 2, 20, and I'm going to find something that looks also real close, and I'm going to say that 6, 35 looks like a pretty solid point on there. So I'm going to do 6, 35, okay? So I've got my 2 points, and now from here I'm going to find out my slope, okay? Well, from 20 to 35, that goes up 15. Okay, and from 2 to 6, that goes up 4. So I have a slope of 15/4. Okay, which in this case, oftentimes with line of fit, we're going to use decimals. So 15/4 is what? 3.75. Okay, so I'm going to use that slope now to find my y-intercept. So here I'm going to do y equals mx plus b. Okay, I'm going to go ahead and grab a couple points here. So I'm going to use 2, 20. So I've got 20 is equal to the slope, which I'm going to do 15/4 right now because I'm using 2, and I think it's going to be somewhat easy to do. So I'm going to multiply this by 2 and get plus b. So I'm going to get 20 is equal to, well, 2 cancels out with 4, so I'm going to get 15/2, okay, plus b. Well, 15/2 is 7.5, so if I subtract 7.5 from both sides, I'm going to end up with, what, 12.5 is equal to b. So Now that I got this, let's go ahead and write my equation of my line. So I'm going to put it in as y equals, and I'm going to use decimals now, right? Because I ended up using a decimal here, so I'm going to use a decimal here. So y is equal to 3.75x plus 12.5. Okay, now this is the equation of my line. Okay, what I did is we created a scatter plot, right? We drew a line of best fit, and then we generated 2 points from this line that looks, they're not going to be perfect, but we're going to generate pretty close ones. And then we use that to find the y-intercept, and we plug it in. Okay, and you could have used, the point slope form. I just chose to use slope intercept. It's a little more familiar for me. But whichever one you feel like using. Maybe in the next one I'll use. We'll see. Now, I'm going to show you in a minute here another way how to use technology in order to use our line of fit, and that's actually called linear regression. Okay, but we'll get to that in a second. Let's go ahead. Let's take a look at another example here. Okay, so we're going to use this data to write an equation for this information. So let's go ahead and I'm going to just pause the video and plot the data real quick. Okay. So here are my points, and now I'm going to go ahead and I'm going to draw in a line of fit. And so I have a you can't see this, but I have a meter stick with me, and I'm going to sort of put it in here. And what I'm going to do here is I'm going to look for a line that kind of goes through this data somewhere in here. Let's take a look at that. Say that looks pretty good. I got 1, 2, 3 points below the line, and then I've got 1, 2, 3, 4 points above it. And these the ones above it are a little bit closer than the ones below it. So yeah, I'm going to say this looks pretty good. Okay, so now what I want to do is now I'm going to generate 2 points from this line that look like they're pretty close on here. So this one looks real good here. I'm going to use this point, and this is why you got to be careful. Okay, so this point is 1, 2, 3. It's 3, 2, 4, 6. It's 3, 7. Okay, and this is why I have to use the point on the line, because 3, 8 is actually one of the points, the data points. Okay, but I'm not using the data points. Once I've generated this, I'm not going to use the data points anymore. I'm going to use the line. Let's see if we can find another one. Well, I hesitate doing this, but this one actually looks like it's pretty close, so I'm going to use this one. Even though it is one of our points, it's 6, 12. Even though it is one of our points, it almost goes through the line, and I think it's about the best one I can use on here. I hesitate using 0, 2. It's not quite there. Plus, it's not my y-intercept. So, all right. Well, let's go ahead. Let's find out what our slope is. So, slope here is going to be from 7 to 12. That's going to go up 5, and then from 3 to 6 is up 2. No, not 2. 3. 5/3. Okay, and I'm not going to put that into a decimal because that's going to be a repeating decimal. And so for right now, well, actually, we could do this. We could say it's 1.6, and it's 6 repeating. We'll call it 1.67. Okay. So now what I'm going to do is now I'm going to find my y-intercept. So let's go ahead and we'll do y equals. Whoops. So I got let's use this point. Okay. So I got 7 is equal to 5/3 times 3 plus b. Okay, and this is going to be nice because 3 and 3 are going to cancel out, and I'm going to get with 5. So 5 plus 2 is equal to b. And actually, remember how I said I hesitated using that point down here, but it wouldn't have mattered because we ended up sort of using it anyway. Okay, so b is equal to 2, so my line here is going to be y equals 5/3 x plus 2. Now I'm going to put it in the decimal form here as well, only because when we do our linear regression I want to have a decimal so you guys can see it. Okay. All right, let's do this. Let me put I'm going to put a box around this thing just so. Oops, that's not a box. Let's see. There we go. Just so you guys can see it a little bit better. Okay. All right. So that's what I have here. Put a box around this one also. Okay. So those are my equations of my lines. Okay. Now, like I said, we call that the best fitting line. Okay. And linear regression is when we use it, the process. So what we were just doing there is called linear regression. Now, technically, linear regression will be used using technology. Okay, and so you can use a graphing calculator, which some of you will be using next year, but nowadays I find that you can just do it online using a web service way easier. So I just ran a Google search using linear regression, and I found 2 different points or 2 different sites, and I'll show you the 2 that I used and how I came up with it. So it's a good way of going through your work and checking to making sure you feel like you did it correctly. Maybe if you made some mistakes, something like that. But we'll do some practice. Don't worry about it. And then if anytime we use estimate information in between values, we're going to call that linear interpolation. So like, if I've got this data here and I wanted to figure out how much was in 1994, for instance, then I would be doing linear interpolation. Okay, and again, if you're not told, this is in that video from last year if you want to take a look at that. And then extrapolation, that's when we're going to use it to find values outside of the range. So like in here, well, let's see, is there another one? Oh, for in here it would be like, what was it like in in 2001, or CD singles shipped in 1989. Okay, that would be extrapolation. Okay, well that's the general idea of all these. So I'm going to go back here and I'm going to go back to these 2 equations, and let's go ahead and no, I don't want to do a scheduled scan right now, so we'll close you for right now. Let's go ahead and I'll take a look at these different the different plots here. Okay, so here's is this the first one? Whoops, sorry. Let's get you back. All right, so here's, yes, this is the first one. Okay, this is the one with the bird clusters. All right, so I created, I put in my X and Y values here, right, just the numbers, and then you click in submit data, and then it generates a plot. And then what I'm going to do is, you can see here, see this linear regression, and now you know what that means is it's going to create a line for me. Okay, and so once it's created a line, okay, I guess it's not going to create a line. Hold on, let me fix this. Alright, I got it fixed now. Okay, so you can see, right, it creates a line there for us, and it gives us, here's the crazy equation. Alright, so, but we're just gonna round. It looks like it's about 12.5 and 3.7x. Alright, so what did we get? We got 3.75x and 12.5. That means our line is really close, okay? And it might be that our line is actually really good, but our point, maybe this point isn't perfect, so we didn't quite do it right? So, and then let's see here. So these are our equations for the second values, all right? And let's go ahead, and I have another one that I did here, okay? And I created this table with using the data, okay? And so we're going to find the equation of the regression line, okay? And we'll go ahead and compute, and we'll see what happens. And here's our value, and here is our line of, okay, and they have 1.58x times 2 or plus 2.3, and they'll do this oftentimes. They'll put the slope afterwards, and they'll put the y-intercept first. So let's see, what did we get? 1.67x plus 2. Let's see what they got again. 1.58x plus 2.3. So we're a little bit off. So it means their line is a little shallower than ours. But that's how we do it. And you can adjust it. And we could have adjusted it here. Maybe my line is, like I said, it's probably a little bit too steep, but it's still pretty close, I'd say. Okay. Well, thanks